All right. How's everybody doing? Let's let's get to it. So I want to talk to you a little bit about some of my experience applying artificial intelligence and machine learning to testing. So we've been hearing a lot about AI. We've been hearing a lot about ML. So I wanted to share with you like my own experience with this, having actually lived in the trenches, trying to apply this stuff at Ultimate Software. So about 3 years ago, we actually came up with the following mission statement. So we wanted to find at least 25% of defects that were introduced into any new software that we built autonomously with zero input from humans. So we set out on this journey, and when we first put together this mission statement, it seemed like, hey, piece of cake, right? 25%. We should be able to do this. We should be able to automate this. We've got all the tools we need. There's so much research out there. So we put together a team. We had a fellow of software engineering, director of quality engineering, 3 test architects, few software architects, and by the way, amongst the people on the team, we actually had a few PhDs, all specialized in testing, and we even had a master inventor with over 150 patents. So again, piece of cake, right? We got this. So let's fast forward a lot of time. I'm going to spare you from the details. I'm actually going to show you just a really quick demo of something we were able to accomplish. So this is basically one of our enterprise applications at Ultimate Software, where we actually built a system that could autonomously kind of explore this application and could figure out all the different states. And as you can see, it's quite complex. So this is not a really simple app. It's a really complex application with multiple roles and a lot of different pages for each of these roles. But nonetheless, we made quite a bit of progress, and we were able to automatically explore these states, which now kind of opened up the door for us to do some testing, right? So let's fast forward some more time, actually quite a bit of time. Let's see where we were able to get to with the actual testing side of things. So this is just a really quick screenshot for a really quick video of drilling into one of our test execution runs. So these are like 3,600 test cases that were fully autonomously generated by the AI. No human input whatsoever. And we can actually drill into some of this stuff. We can see different types of test cases, boundary test cases, equivalence class partitioning, so on and so forth. And we can actually drill in and expand the test case. And hey, it's actually mostly in English. That's cool. So you can actually read the steps that was generated by the machines. So it looks like we made a lot of progress. So I'm going to highlight just some of the things that kind of stand out here. So as I mentioned, we were able to generate test cases, about 3,600 in total. That's quite a bit. But when you actually start looking into some of the details, you'll start to notice that a lot of these test cases are actually quite simple. So these are really simple test cases that really are testing, say, a phone number field based on our expectations of how phone number fields should work. We have some expectations based on, hey, there are valid phone numbers, there are some invalid phone numbers, and if we use open test data, we get probably a lot more interesting test cases. But we have some expectations of these different inputs, right? So we can generate some of these tests quite easily. So we made some progress there. We also were able to generate, to actually learn a little bit from the application under test. So if the application spit out an error message to us, then we use natural language processing. We try to decipher what it's trying to tell us. So we could learn a little bit more about it, and so we can generate more interesting test cases that are a little bit more closely related to the application under test. So we did some of that, and we also did some boundary testing. So once we know about a particular boundary condition, maybe an error message clued us in on, then we can generate some additional test cases. So if you kind of sum all of these different techniques, or you take these different techniques and you generate all these test cases across all of those states that I showed, you get about 3,600, sometimes 4,000 test cases, which is really useful if you really think about it. But when you start looking at this, it's a lot of progress. It's really awesome. But at the same time, there's a lot more work to do. And that's because of the Oracle problem, right? So when we start looking at different types of failures, we have actually, if you take software defects and software failures, you can pretty much bundle all of them into one of these 5 categories. So on the top left here, we have superficial defects. So this is if something crashes, if the application just quits, right? That's something that you should be able to very easily see and teach the AI to see easily. Patternized, so this is all like when it's a failure that you can find by using something like boundary testing. Expectational, so this goes back kind of to the phone number example. So we have certain expectations of how phone numbers should behave, so we can generate some of these tests. But then we start to get into functional and deep, right? And functional really is about, does the software do what it's supposed to do? Does it meet the requirements that were written for the software? And some of the deeper things, like what happens if I actually try to test this with concurrent users? What happens if the stars align in a certain way and a very specific edge case happens, and maybe it's $1 million defect, right? These are the things that we're really good at, right? We're really good at all of this, but we're very, very good at functional defects, finding those, and finding deep defects. Why? Because we humans bring a lot more to the table than just, does a phone number work, right? So that's something that we learned, and something that we learned the hard way by actually trying all this stuff and by trying to, again, that mission statement of trying to find 25% of defects autonomously. And it turns out that when we actually do the studies, most of the defects that our customers are finding are the deeper defects. More than half of the defects that they're finding are things related to really complicated data conditions, not understanding how the product is supposed to work because it's so complex. So really, it's a lot harder than it looks when you actually start peeling the onion. And when we started doing this research, we realized that solving the Oracle problem is actually not an easy feat. There's a lot of research out there, and we put together this huge mind map on all the different topics, and there's probably some stuff that we missed, to actually start drilling into this problem further. And we even took it a little bit further than that. We said, okay, maybe we can try to parse the requirements. So the requirements are written down. They're in English. We can go read them as humans, and we can understand what the software is supposed to be doing. So we've also done some experimentation on building software that can do the same. So we have all these neural networks out there. Why can't we just take a network, really complicated network, throw it at the problem, and see if we can maybe gather some insight? And that's exactly some of the stuff that we're doing now, some of the more difficult things to see if we can further automate the solution of the Oracle problem. So let's fast forward maybe a few more years into the future. And really, the question is, where are we going to be 10 to 15 years from now? Nobody really knows, but the reality is that yes, we've made a lot of progress, and I want everybody here to know that there's a reason that we're all here, and there's a reason that we are testers, and there's a reason that we're paid for it, and it's because we bring a lot more to the table than the machines can bring to the table right now. Thank you.